All right, folks, here we are. We've made it to solving trigonometric equations. Okay. Now, I want to say something. In this class, and also if you move into calculus, generally speaking, most of these kinds of problems are always solved in radians. So that's what we're going to do in this class. That's what we're going to do in this lesson. So make sure your calculator is set for radians when you're going to solve these problems. Okay. All right, so what I've done is here, let's go ahead and read the question, and over here I've given a 6-step procedure. It's not perfect, but it'll get you most of the way, okay? Well, it'll get you all the way to the end, but I mean it's mostly correct. So it says here, solve for all values of x. Now remember, with trigonometric functions, especially sine and cosine, you can have an infinite number of solutions. You can have an infinite number of solutions. The reason I say can have an infinite number of solutions is because once you get to trigonometric equations where you start throwing weird extra things in with cosine and sine, you may actually come to a place where you only have 1 or 2 solutions, okay? But we're mostly going to work still with infinite number of solutions, okay? So this says solve for all values of x such that x is between 0 and 5. We only want the answers that are between 0 and 5. The other question is, how many solutions are there on the interval from 0 to 5? So you're answering 2 questions here. The first one is, how many solutions are there? And the second one is, what are those solutions? Okay. So here's what we're going to do. Here's our equation. 4 times cosine of 2x plus 7 is equal to 10. Now this thing right in here, whatever is inside the parentheses, that represents the theta angle. That represents the angle. This plus 7, not part of the angle. This 4, not part of the angle. This 10, not part of the angle. All of that stuff is just extra algebraic stuff piled on top of the cosine function. Okay? So here, this is what we're trying to isolate here, okay? And so here's what we're going to do. Your first step in solving a trigonometric equation is you're going to algebraically manipulate the equation until all you have is sine or cosine of the theta angle is equal to some number. So you want to get rid of everything that is outside of cosine of 2x. You want to get rid of the 4, you want to get rid of the plus 7. You want to move those things over to the other side of the equal sign algebraically. First thing we're going to do, you might think, hey, we can divide by 4 over there. We don't want to do that. You don't want to divide by 4. The reason you don't want to divide by 4 is you would have to divide this by 4, then you'd have to divide this by 4, and you would get 7 over 4. You don't want to mess with plus 7 over 4. Let's get rid of the pluses and the minuses first, okay? So we're going to subtract 7 here, and subtract 7 here. That's going to cancel the 7 here. Bring down 4 cosine of 2x equals 10 minus 7, that equals 3. Now we can divide by 4. Now we're going to divide by 4, cancel, divide by 4, and now what we have is cosine of 2x is equal to 3/4. Now you can write that in as 0.75 if you want to, but I'm going to leave it as a fraction for now. Now it says, so we've done step 1. We now just have cosine of the theta angle is equal to a number. Okay? We're there. Now it says apply sine inverse or cosine inverse. Basically what we're doing is we want to cancel cosine or cancel sine. In this case, cancel cosine. So we need cosine inverse of this. And we're also going to do cosine inverse of 3/4. We're going to cancel cosine, carry down the 2x. 2x is now equal to cosine inverse of 3/4. Now there's a couple ways you can go here. Yes, you can divide by 2 over here and you have a solution for x, but that's only one solution for x. You want a bunch of solutions for x. So here's what I'm going to say we're going to do at this point. We're going to leave this 2x alone just for a second. We're going to leave it right over here. We're going to come over here and we're going to identify the first 5 positive radian angle measures. This is the angle. 2x is the angle. Not x. X is not the angle. Look up here in the parentheses. 2x is the angle. So instead of saying x equals this, x equals this, x equals this, this, and this, we're going to say 2x equals this, 2x equals this, 2x equals this, etc., up to 5, just like we did in the last lesson. Okay? So let's go ahead and get a calculator. We're going to do cosine inverse of 3/4. All right, cosine inverse of 3 over 4 gives us 0.7227. Okay, so, and here's what I'm going to write. Instead of x equals, I'm going to write 2x equals 0.7227. Now that's a first quadrant solution right there. Okay. Now it doesn't matter first or second quadrant because we know that the next one, the way we get it, remember with cosine, all we have to do is subtract this from 2 pi and we get our second solution. Okay, so 2 pi minus 0.7227 gives us 5.5605. All right, so first quadrant, this is now fourth quadrant. Remember, with cosine, we get first quadrant and fourth quadrant go together. Now we're going to need the next first quadrant. And so remember what we do, we have to take this one and we have to add 2 pi. We need a coterminal to this. Then for the fourth one, we need the coterminal for this. So we're going to take 0.7227, we're going to add 2 pi, and we get 7.0059. Okay? And now I'm going to move over here for the next one. See, I need space. I'm going to show you why in a minute, why we need space under each one. Now I'm going to go 2x is equal to, we're going to take 5.5605 and we're going to add 2 pi, 11.8437. I really hope you're doing this with me and not just watching me do it. You should have a calculator in front of you. If you're not doing this with me, you're not getting your learning. Okay? You're just watching me do something cool. All right, so last one, 2x is equal to, so we're going to take this one, and we're going to add 2 pi, so 7.0059 plus 2 pi is 13.2891. Okay? All right, so what we did was we just identified the first 5 positive radian angle measures, then we're going to set all 5 of those from step 3 equal to what was inside the parentheses. Okay, see the question mark up here, the question mark above, whatever was inside the parentheses. In this case, it's 2x. We already did that. Look, we did step 3 and step 4 all at the same time. Okay, so now we've set each one of these 5 equal to 2x, which is the angle measure that's inside of the parentheses. And now step 5, solve all 5 equations from step 4. Look, we have 1, 2, 3, 4, 5 equations. We're just going to solve them now. Well, these are easy. All we have to do is divide by 2 on both sides, right? Divide by 2 and x is equal to 0.7227 divided by 2 is 0.3614. Okay? Next one, okay, so that's the first one. Second one, divide by 2, cancel. 5.5605 divided by 2. That's going to give us x equals 2.7803. Okay, that's the second one. Now this one, divide by 2, cancel, divide by 2, 7.0059 divided by 2. That gives us x equals 3.503. All right, good. Now the fourth one, divide by 2, cancel, divide by 2. X is equal to 11.8437 divided by 2 gives us 5.9219. Okay. All right. Hang on. Fix that. And now last one, divide by 2 on both sides. X equals 13.2891 divided by 2 gives us 6.6446. 6446. Okay? All right, that was step 5, solved all 5 equations. Last thing we're going to do, select all solutions that are on the given interval. All right, so here's the thing. When we originally did this, look, we had, you might have thought that this was a solution, and this is 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 a solution, right? Those aren't solutions for x, those are solutions for 2x, those first 5 numbers that we got. And you might have said, well, this one is between 0 and 5, and this one is between 0 and 5, but this one, and this one are not between 0 and 5. Therefore, you might have thought that there were only 2 solutions. But remember, we're not looking for solutions for 2x. We're looking for solutions for x. So we have to divide all those numbers by 2. And now here are our solutions. 0.3614, 2.7803, 3.503, 5.9219, and 6.6446. And what we want to know is how many of those solutions are between 0 and 5. This one is not between 0 and 5, and this one is not between 0 and 5, but these three are. So there are 3 solutions between 0 and 5. And what are the solutions? If we solve for all values of x, where x is between 0 and 5, these are our 3 solutions. And what you would then enter, here's what I want you to do. When you take the quiz, I want you to go to 2 decimal places. So what you're going to enter in the box, in addition to telling me that there are 3 solutions on 0 to 5, you're going to enter x equal, you're going to have an x equals there, and then there's going to be a box. And you're going to put, this one's going to be 0.36, 0.36. The second one is going to be 2.78. And the third one is going to be 3.5 or 3.50, but I would just put in 3.5, okay? And then then we have succeeded in solving this trigonometric equation for all of the solutions that are between 0 and 5, okay? I think we should do at least a couple more examples. All right, here's our next example. It says solve for all values of x such that x falls between 0 and 10. And how many solutions are there on the interval from 0 to 10? Okay? And we've got 4 sine of 3x over 2 minus 11 is equal to negative 12. All right, so the first thing we're going to do is we're going to algebraically manipulate everything that is not the trigonometric portion. Okay? So let's go ahead and add 11 to both sides. Cancel, and we get 4 sine of 3x over 2 equals negative 12 plus 11 is negative 1. Now we're going to divide by 4 on both sides, divide by 4, and we get sine of 3x over 2 is equal to negative 1/4, or negative 0.25. I'm going to leave it as negative 1/4. Then it says apply sine inverse or cosine inverse. Well, I'm going to apply sine inverse because this is a sine function. And here's my angle measure, and here 3x over 2. I'm going to leave the 3x over 2 as 3x over 2. I'm not going to mess with that. I'm just going to do sine inverse here, and I'm going to do sine inverse over here. I'm going to cancel sine here, and I get 3x over 2 is equal to sine inverse of negative 1/4. Okay? Now I can do this in the calculator. Make sure you're in radian mode. And I'm going to do sine inverse of negative 1/4. And that tells me that 3x over 2 is equal to negative 0.2527. 0.2527. Now, this is a negative value. Remember, see what this says? It says, now, by the way, this is my thing. This step 3, that's my thing. Okay? If you get out there in the world and you're trying to really identify real answers, you're going to have to decide which range of angle values you need. I'm telling you because I have to put limits on everything. Otherwise, you'll have 5 million answers. I have to tell you just to stick with the first 5 positive. Okay? But this is not positive. Okay? So what I need to do is, but we do know that it is a 4th quadrant solution. Okay? Because it's negative off of sine inverse, and all the negative output, all the negative answers to sine inverse are in the 4th quadrant. So remember what I said to do is that you should add 2 pi to this. Add 2 pi, and that'll give you your second answer. You then have to use that and go backwards and get your first answer, which is in quadrant 3. Okay? So we're going to take this negative 0.2527, and we're going to add 2 pi, and that gives me 6.0305. So my second answer, 3x over 2, is equal to 6.0305. My first one, which is going to come from quadrant 3, to get that one, I have to do 3 pi minus this number. 3 pi minus 6.0305, which gives me 3.0305. 3943. Okay, it's rounded to 4 decimal places. So this is a quadrant 3, this is a quadrant 4. Now it's going to be easy to get my other 3. So 3x over 2. I'm going to take this one and add 2 pi. And I get 9.6775. Okay? Then 3 pi over 2 equals, I'm going to take this one and add 2 pi. 6.0305 plus 2 pi gives me 12.3137. Last one, 3 pi over 2 equals, I'm going to take this one and add 2 pi plus 2 pi. So coterminal to this is 15.9607. 15.9607. Okay? And now what I need to do, so I did steps 3 and 4 both at the same time. I've set them all equal, all 5 of these, the first 5 positive radian angle measures. I'm setting them equal to what the angle measure is represented by, right? The expression representing the angle measure is 3x over 2. So I set them equal to 3x over 2. Now I'm going to algebraically solve. So I'm going to multiply by 2 on both sides. Actually, the best thing I can do here is, remember how to do this? Oh, that's an x. That's not a pi. I'm so sorry about that, folks. I meant x there. X. Oh, I put pi's here also. It's x. 3x over 2. Man, I am a dummy. Sorry about that, folks. My brain just got in the way, or my brain got too relaxed. Okay, so 3x over 2. See, 3x over 2, 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 3x over 2. Okay. So what I can do here to cancel the 3 over 2, I can either multiply by 2, then divide by 3. That's 2 steps, right? Or I could just multiply by 2/3. The reciprocal of 3 over 2 is 2 over 3. That'll cancel the 3 over 2. Okay? And so this cancels this, but I also have to multiply over here by 2/3. So I'm going to do 3.3943 times 2 divided by 3. I'm putting that in parentheses just to be safe. And that gives me x is equal to 2.2629. And that is my first solution for x. And that is between 0 and 10, so that's one of my solutions. Okay? Now here, I'm going to multiply by 2/3 again, and that's going to cancel these, leaving x equals, multiply by 2/3 over here, 6.0305 times 2/3 gives me 4.0203. Okay? All right, there's my second solution. Also between 0 and 10. So for this one now I'm going to do multiply by 2/3 on both sides. It's going to cancel these, bring down the x, equals 9.6775 times 2/3 is 6.4517. All right. Now for the fifth one, and this one is also between 0 and 10, so far I have 1, 2, 3 solutions. This one, again, I'm going to multiply by 2/3, cancel, multiply by 2/3, x equals 12.3137 times 2/3 gives me 8.2091. 2091, still between 0 and 10. So I have 4 solutions so far. And this last one here, we're going to multiply by 2/3, both sides, multiply by 2/3, bring down the x. 15.9607 times 2/3 gives me, just barely outside, 10.6405. This is not on the interval from 0 to 10. Therefore, we have 1, 2, 3, 4 solutions. The 4 solutions are x equals, going to 2 decimal places, 2.26. X equals 4.02. X equals 6.45. And x equals 8.21. We've got to round that. 9 rounds that 0 to 1. 8.21. And there are our solutions. 4 solutions, and that's them.